Oh, the transcript starts, and that's always the thing that puts me off. Then, when it starts and it starts rattling down the screen at me, I can't help but reading my own transcript as I speak and realize how I make no sense. But
The
right, hide
Copilot's
that.
great as well. Reading
Oh,
the
it is, yeah.
summaries of a
Copilot's
meeting.
been brilliant. I tell you what, I absolutely love Copilot now in Teams meetings.
There we
It's
go.
like,
If anyone was playing along with the bingo card, we've mentioned Copilot just as the meeting started, so you've all won.
yeah, I know exactly. All right, okay, I think we are good. Yeah, all right then, let's get on with it then. So, yeah, hello everybody. It's the 17th of April, can we believe it? Time for the Welsh Azure User Group, April edition. As per usual, thanks everyone for joining. Quick splash of this card. I should really update this, Matt, now and get this up to date now. But as usual, community user group. It's mainly myself and Matt now that kind of front the group more than the others on the team. But feel free to reach out to any of us if you've got any thoughts, ideas, you want to take part, you want to speak, we can get you the sessionized link sent over. Please help us spread the word. We say this every month on the sessions, but we're really trying to obviously get the word of the Welsh Azure Use Group out and about. Certainly in the realms of South Wales would be great for us. But equally, because we were born during the COVID times, we've kind of started to attract people from not just around the UK but around Europe and America, India. So look, we want to stay virtual as much as we can. And I know me and Matt keep talking about getting back to an in-person event, and I'm sure we'll get there, Matt. Right? We'll
Maybe
get there at
one
some
day.
stage. One day, yeah. But
We're a bit less busy.
virtual is just so nice,
It works.
and it works. So, but look, fundamentally, it's a user group for the community. So feel free to reach out to us. Add us on LinkedIn, Twitter, X, whatever we call it these days. Really great to have you all here. So April event, yeah, as per usual, another two great speakers. Huge thanks and appreciation for the two guys that join us tonight to give up their time and talk us through some goodness. Jake, always a pleasure to see you, Jake. I know you just joined. I just saw your name pop up now. We're going to kick things off in a second with Jake, who's going to give us an introduction to Terraform. So super excited to see that. I know Jake's HashiCorp ambassador as well, so we're in safe hands there. If you need to know or get down and dirty with Terraform, then this is really great way to start that journey. So we'll kick off with Jake as soon as I've started rattling. Bear with as I throw a cushion at my cat who's trying to eat a piece of pizza off the box. Sorry about that. Yeah, and then we'll have Nara joining us to talk about Workload Identity Federation. Again, Nara's across the pond in the US, so nice and early for him. So huge thanks to Jake and Nara for giving up your time today and coming to educate us, because that's what fundamentally it's all about. Timing wise, there's a bit of timing, apologies if you are in other parts of the world. I'm clearly not that clever to put any timings up there, but look, it's 25 to 7 for us now in the UK. Jake will be on in 5-10 minutes. Nara will be joining us about 45 minutes later. We'll go straight into Nara's talk. Interesting, just speaking about it before I hit record, but those that joined us last month will know that we have had another sponsor join us in Packet. So not only have we got a couple of gift vouchers up for grabs in the quiz, but we've also got a couple of ebooks. And this month we've got the Azure IoT Handbook by Dan Clark to give away. It's an ebook, so it's a downloaded version. And Implementing CI/CD Using Azure Pipelines by Roberto Mardeni. So I think what I did last month is we just did top 4. So, at the minute, and there's not that many of us in the chat, there will be more hopefully joining my preamble is just to allow people to filter in pretty much. So hopefully we'll get a few more people by the time we get to the quiz, but at the minute it's looking good for a prize. So please do stick around for that in a bit. A couple of quick housekeeping rules and I'll shout out to our sponsors as well, as we usually do. So from a housekeeping perspective, the usual thing, it should go without saying, I'm sure it does, but please be courteous to each other. We're all grown adults and we're all here to have a little bit of fun and to learn some good stuff. There are no silly questions. Any questions that we need to ask, please use the chat facility. Stay on mute until, unless one of the speakers, invites you off mute. You've all got control of your cameras and your audio. So, the usual kind of house rules there. Just stay on mute unless you're invited to come off. Use the chat window if you can to ask those questions. Be interactive in the chat. If you know the answer, help somebody out. Please feel free. Part of this is a little bit of networking as well, as much as we can in this virtual space. So, be interactive. Get your gifts on the go, and keep that chat flowing throughout the sessions. I normally put a QR code at the end of the event just to collect some feedback. If you do have 2 minutes to scan that and give us a little bit of feedback at the end, that would be great. The quiz will be, using our it's got to be famous Quizzer platform now, right, Matt? This is
legendary. I think is the word
legendary.
Yeah,
legendary Quizzer platform.
Yeah,
I say it every month, isn't it? It's that is an open source repo available at Matt Fatunka's GitHub repo, right?
We'll make that available to people if they want it. Absolutely.
It's great. And if you haven't seen it, I forget when it was, Matt, but you did a session. Go back through the YouTube library and look for Matt's name, because it was a great session showing how Matt fundamentally built a I don't know, a Kahoot style.
That's probably the best way. Yeah.
Kahoot style quiz platform that runs off Azure and gets down and detailed with all cool stuff like app insights in there. So yeah, go and check that out as well. Most importantly, look, be interactive in the sessions. Enjoy, have a good experience in this session. Quick one on, as I do this every month as well, obviously, we're hugely supported by our sponsorship, as we just mentioned. Packet came on board with us this last month. Servant have had a bit of a facelift in terms of marketing, so you'd have noticed the logos have slightly changed, got a little bit of new brand into them. They've got some marketing teams on the go now. So if you don't know Servant, look them up. They are a really kind of valued Microsoft partner. They've been with the user group since pretty much day one, which I can't believe we're coming up to 4 years now, Matt. But it's about 3.5 years. It'll soon be 4. But Des and the team have been with us, supporting us, with these spot prizes. When we did a face-to-face, they're a great kind of sponsor and ally for us, and they do a lot across the community. So if you don't know them, please feel free, look them up, reach out to them. Great partner. They're an Azure house. They do anything and everything pretty much in Azure. And I can attest to that as well. With firsthand, having worked with the guys. So huge thanks to Servant. Same treatment as well. It was great actually that we were able to find a locally HQ'd company to come on board and sponsor us. And in fact, we're really looking forward to next month when we've got Ridian joining us from Credit Safe, who is going to be on to talk about their kind of multi-cloud journey, I think it's best to say. So he's putting that together at the moment. So he's been telling us he's going to be coming on for a while. So he's finally nailed down the date. He'll be with us next month. So usually customer stories and customer success events and kind of talk throughs really go down well. So if you're interested in looking at how Credit Safe have done things, if you don't know who Credit Safe are, there's a little bit about them there. But yeah, really looking forward to those guys coming on board and giving us their story next month as well. But big shout out to Credit Safe for being there again to support us from that kind of sponsorship perspective. And last but by no means least, our latest sponsor, come on, Packet. Like I say, I didn't realise that we're actually established in Birmingham, of all places. I didn't realise they heralded from those parts. So, like I say, they're on with us as a sponsor. Again, they sponsor a number of user groups, but with things like ebooks, just enables us to give out those spot prizes during the quiz. And it's, hopefully you'll all agree it's a nice little added benefit when you join a little bit of a tech community. We've got some talks. I'll try and get into the art of trying to maybe align the book title to the topic of that event. I don't think I've quite got that yet. I just said, yeah, give me some books. And so I think I mentioned earlier, we've got CI/CD pipelines and the IoT handbook to give away.
You've done all right on the CI/CD one.
Yeah, actually, that's
CI/CD was pretty good. Yeah,
automation, Terraform, CI/CD, kind of all it's the right thing, didn't it?
Yep, absolutely.
So that was more luck than judgment, Matt, right? But look, hopefully you'll agree. Hopefully that makes sense of what we're all about. Always open to any ideas and thoughts from the community. But like I say, that's the end of our little thank the sponsor section. So with that, I'm going to be quiet and hand the microphone over to Mr. Walsh, who I can see waiting in the wings, and let you take the floor, sir, if you're ready.
Thanks, John. Hello, everyone. Lovely to be with you. I will seamlessly switch to my PowerPoint. Bear with me a second.
And long time no see, by the way, Jake. Hope you're keeping well,
good
sir.
good to see you, John. Hopefully that's showing up okay.
Perfect. Got you. Over to you.
Awesome. Brilliant. Thank you. Yeah, so hi everyone. So this is an introduction to Azure Terraform, sort of an exciting sort of 40 minutes today, well, this evening, where I'll take you through quite a few different things. So let's get started. So a quick intro from me. My name is Jake Walsh. I'm a senior solution architect. I work for CDW UK. You can find me over on X, formerly Twitter, at JakeWalsh90, and over my blog at jakewalsh.co.uk. Lucky enough to be a Citrix CTA, also HashiCorp ambassador, and also a Microsoft MVP for Azure. Probably should point out as well that's thanks to John, who nominated me. So thank you, John. But yeah, great to be here, and yeah, please feel free to fire any questions at me. More than happy to take questions both online and offline. And just help out as best I can. So session goals today, really, we're going to start with kind of a bit of context, bit of background. What actually is infrastructure as code, and why would you use it? What's the reason for me being here? Have I come here because I love infrastructure as code and I want to scream about it? What's the actual benefit and why would you use it? We'll talk about what Azure Terraform is and sort of specifically go into a few things about Terraform that I think are relevant. We'll talk about how Terraform works as well, and why it's relevant. And the works is really quite important. Sort of understanding those building blocks will help for the future if this is something you want to use. We'll briefly cover getting started, and the sort of installation and the things you need to set up to use Terraform. I'm then going to take you through a code sample. I have got a demo running as well, just depending on time. Obviously, I've had my Blue Peter moment. I've pre-deployed my demo, so here's one I made earlier. But yeah, I'll just kind of show you what that is, and that demo is something I can share as well if you want to try it out and test. So let's just talk about what infrastructure as code is. So infrastructure as code, IAC, you've probably seen lots of different things about it, but it's actually a method of managing and provisioning infrastructure via code. So rather than what some people might call ClickOps, where you're in a portal or something clicking around, this is defining it in a code base. In most cases, that's either imperative, and by imperative code, it's doing something. So a piece of code that goes off and does a task, whereas declarative code, that's what Terraform is more of a build this. It describes the completed object, the finished article, and that code is then run to build that. It's often, not always, and the caveat here is that for most of the sort of lab things, when you're learning about Terraform, you're probably not going to integrate it into a version control system. The version control system is probably going to be a folder on your desktop or something similar. But in sort of enterprise scenarios and production scenarios, it would be integrated into a version control system to give that control, to give that track change. It can be edited and managed in most common tools and platforms. So think of things like GitHub, VS Code, Azure DevOps, GitLab. There's a whole host of platforms and solutions out there that will allow you to do that. For the demo today and the code I will show you, I'm just using VS Code. There's nothing I'm going to demonstrate today other than the Azure consumption that would have any cost attached to it. So if you've got an MSDN subscription or perhaps access to a lab subscription through your employer or something like that, you can test out what I'm doing today, and the only cost is anything you run in Azure as a result. It's worth calling out as well that infrastructure as code is not normally done in isolation. Sometimes it is. Today, for example, I'm doing IAC in isolation, but it's usually adopted as part of a wider DevOps strategy. So perhaps an organization that's looking to do lots of things in pipelines, deploy infrastructure, manage their applications, carry out common tasks, that sort of stuff. And infrastructure as code allows a move away from ClickOps. We're all human beings. If I sit in a portal, I go into the Azure portal and I click around and build something, and I do the same thing 10 times, well, the chances are one of those 10 times, in my case, probably many more than one, I'll probably get something wrong. But having it defined as code means we can do things repeatedly. And I'll come on to that a little bit later on. So I talked about imperative versus declarative. So imperative code defines a task to be carried out. So here's a very basic example I've taken from Microsoft Docs. This is an Azure CLI command requesting the creation of a virtual machine. And if I run this more than once, it would error and it will come back saying, can't do this because the VM already exists. And that's typical of kind of imperative code. You might have seen this when you're working in Azure before. When we talk about declarative code, and this is a screenshot from the example Terraform I'll show later, but actually it's not asking for a task to be carried out, it's defining infrastructure components that will be created. So in this example, you can see there's 3 resource groups being created. They've got some tags. One of them is defined explicitly. The other is based on a variable as well. But if we ran this multiple times, so on the first execution, for example, it would say, oh, I need to build you 3 resource groups. If I then ran it again, it would say, I don't need to do anything. Those 3 resource groups already exist and you wouldn't receive an error message. So that's just a key example that's important to be aware of. This slide, to be honest, could be the subject of much debate and probably could be an hour-long session, of discussion in itself quite easily. But for me, there's 3 main things as a sort of why would you use infrastructure as code. The first is cost. Once you get comfortable with using infrastructure as code, you become more rapid in the way you deploy. Changes are quicker. You can spin up test environments, and the outcome of that, when you look at all of those, really in a business sense, it boils down to that makes things more cost effective. We can work faster. We can test faster. We can deploy quicker. All of those boil down to cost, really. Speed is really important as well. So speed is another huge benefit. Faster deployment due to less manual intervention. Terraform, for example, can work building multiple things at the same time. Now, some people might be able to do that, but for me, I struggle when I, try and do multiple things at the same time. So that sort of, ability to do things very quickly, no click ops, takes away that sort of human error factor, and it makes things like testing much easier. I also touched on, enablement of those DevOps methods and practices. That's another key factor that just increases that speed. Risk is really important as well. So using infrastructure as code, in my opinion, definitely reduces risk. Once you have a known piece of good code, you become more consistent in your deployments. You can use version control systems, and that kind of, when you boil that down, it all leads to reduced risk as well. So this is something I like to call the benefits cycle, and I think a lot of the benefits of using infrastructure as code are cyclical in nature. When we write once and deploy many times, we duplicate code. We become more repeatable. When we're more repeatable, our speed of deployment increases. By having a faster speed of deployment, our risk is minimized, because that code is taken from a known good configuration. With less risk, increases consistency. We become more reliable than clicking in a portal, and it snowballs in nature, and these benefits kind of get larger and larger as you become more comfortable with infrastructure as code in general. And one aspect I would call out, that as your infrastructure as code experience and usage increases, and that's not just from an organizational level, that's also, on a personal level, as you start spinning up lab environments in this way, the level of DevOps and practices and principles that you're using usually also increases. Now, I've said in an organization there, but it's worth calling out that it's not just in organizations. Myself, for example, in my role as a solution architect, I do a lot of demos to customers. Well, most of those are Terraform files that I deploy ready to do those demo sessions. So it's very useful from that perspective as well. I'm just checking the chat to make sure I have any questions. No, cool. So we talked about this kind of, maturity journey. I just wanted to highlight a little bit of that. But when you first start, you're probably going to be working locally with code, doing some editing and deployment. You'll probably then move to putting that code in a remote repo. So perhaps Azure DevOps repos, perhaps a Git repo, and you might start using version control. You might think, well, yeah, this is day one of my lab environment, and I'm going to make some changes, have that version saved, and that's going to be version 2, and you'll start getting comfortable with those processes. And then you might move to pipelines, and the reason I'm using this as an example is this was kind of the learning journey for me. I started locally editing code, playing around, deploying manually. I moved to using repos, I moved to pipelines, and as that journey increases, you'll move to things like custom modules for deployment, building your own configuration files, and you'll start to find that on day one you walk, and then further down the line, on perhaps day 5, day 10, whatever, you'll start finding you're actually running with this, and it certainly becomes very, very fast in nature. So great question as well from Alan in the chat. So why would you use Terraform over another IAC tool, Bicep, Pulumi, for example? Great question. Perhaps one of the key points that Terraform actually has as perhaps an advantage over Bicep. Again, this is the subject. This question itself is one they probably could have a lot of debate around it, but Terraform has multiple providers, and I'll touch on those a little bit later. But for example, in the same Terraform deployment, we could deploy to Azure, we could deploy to AWS, we could deploy to GCP, we could also deploy to our on-premises environment through perhaps a vCenter provider as well. So that's perhaps one of the advantages that Terraform has over Bicep, just as an example. But again, that particular question is certainly one that we see a lot of debate about. So it's worth calling out, and kind of perfect timing from Alan's question there. But there are other platforms available. You know, you called out Bicep and Pulumi, actually the two not on this slide. This is a shameless screenshot from Wikipedia. It's a good job I'm not doing a university presentation here, but yeah, there are other platforms available. And one of the things I would absolutely say as a recommendation is go and try them. Try lots of different things. Get comfortable with lots of different things. Try different approaches. Try different platforms. And you'll soon find one that you start to get comfortable with, and it's very much a case of finding the right one for your particular use case. So let's just talk about what Terraform actually is. So Terraform itself is an infrastructure as code software tool. It can interact with a wide range of platforms and environments. So I talked about things like AWS, VMware, Azure, and it does that using something called a provider. So Terraform is the tool, the language, and the provider is the extension that allows you to talk to that specific target API. So in the demo example I'm going to use, that would be Azure. It can be used in both cloud and on-premises environments. It can be used to combine those, or cloud and cloud, for example, AWS and Azure. And that's kind of one of the key strengths of Terraform. Once you are comfortable with a language, you can kind of work across different providers and platforms, and the same sort of functions, conventions that you've learnt in one can be transferred to another. Three main varieties. I'm using the community edition. That's something you can download and use. There's also a Terraform Cloud, which is a hosted version, and an enterprise, which is a more sort of commercial enterprise product that you can self-host as well. As I said, three varieties. Community, self-managed, always free. That's what I'd recommend you start with if you are on that learning journey. Worth calling this out because I've talked to a lot of people about this, and it's something that often gets missed, but Terraform Cloud is free for up to 500 resources per month. So if you are wanting to just deploy a lab environment, I absolutely recommend trying this out. This is an example I often talk to people, but I actually log in on my phone sometimes when I perhaps need to travel, or I am traveling to a customer to a demo, and I've not had my coffee that morning, I've forgotten to deploy a demo. Using Terraform Cloud, I can actually deploy that remotely. I just need to log in, trigger that run, and it will go off and do it. But it's free for up to 500 resources per month, so it's well worth checking out, because it's certainly something that's that's good to have that awareness of. Okay, so we can't talk about Terraform and we can't talk about moving to a demo unless we talk about authentication. And this is really important. So for demo and lab environments, it's usually authentication at the CLI. So that's an AZ login or done inside VS Code, for example, or it's a service principal. Perhaps you're using Terraform Cloud, or you're building out a pipeline, or you're using GitHub Actions. When it comes to production environments, authentication at the CLI just doesn't really scale. So service principals or managed service identity is really the the route we would go down. And a little bit more on that in a second. I'll switch to a browser in a second when I move on to the provider, just to show you a bit more about authentication. So yeah, the Azure RM provider detail is really good. It has all the information you would need, so you can see it actually gives you options. How do I authenticate to Azure using the CLI? How do I authenticate using a managed service identity? How do I do it with a service principal and client certificate? This is probably one of the strengths for Terraform, in my opinion. The documentation, particularly around the providers that HashiCorp themselves maintain, is fantastic. And I will switch and show you that in a second, but it's worth calling out just how good that is. So I've talked about providers a lot, and I just want to give some context about those. What actually are they? What do they do? What do they help us achieve? So before we can run Terraform, and before we can do anything to an external API or an external resource, Azure in the case of my demo, we need to add a provider to our code. And those providers are plugins for Terraform that allow Terraform to interact with an external API. In the same way that you might add an extension to VS Code to allow you to perform a particular task, providers give Terraform an extension to allow them to talk to a particular platform or external API. So in the case of Microsoft Azure, it's the Azure RM provider that we need to add to Terraform before we can actually interact with Azure. So bear with me a second. I'm just going to switch to my browser. Sorry, in true techie fashion, I've got 10,000 windows and tabs open. So cool. So hopefully you can see my browser window now. So actually, this is from the HashiCorp registry. Again, you'll see this is the Azure provider. Really great documentation. If you want to use the provider, you just tick this, and this is what you would need to add to your provider file. Worth calling out, when you actually browse to the provider, it tells you all about authentication, how you would do that authentication, what you would need to do. But what's really great about this documentation is when you actually start looking to create resources, it will tell you how to do that as well. And I'm just going to put in here Windows virtual. So let's say I want to build a Windows virtual machine. You'll see it actually has an item. It tells me it's an Azure RM Windows virtual machine, and it gives me here a fully workable example that I can go and deploy to actually deploy that Windows virtual machine. And what's really great about the documentation here is it tells me all of the supporting items I need as well. It's not just an example in isolation. This is a workable example. So you will know in Azure, you can't create a VM without having a VNet, without having a network card for it to go on, without having a resource group. And you'll see this example builds that out for you. So this, for me, is a huge strength of the documentation and sort of support that Terraform has in place for you to learn. And with that, I will seamlessly switch back to my PowerPoint. Hopefully that's showing up for you okay. So this is just a kind of an example to show you what the interaction with a provider actually looks like. So you have Terraform that's installed on your machine or it's running in your pipeline. You add that provider to give you the extension. You then are able to talk to that target API. So for example, using the Azure RM provider, that is Microsoft Azure. Just checking the chat for questions. So Alan, in the answer to, so Alan's asked a question, do you need a different code to deploy a VM to Azure than you would do for AWS as an example? The answer to that is yes, you do, because the providers are different. So there are differences between them. They are different resources. However, let's say, for example, you are creating a piece of code, a Terraform deployment that had variables in that would control the names of the VMs, the IP address spacing, the tags. All of that could still be common in your deployment. So you would still have an element of commonality even between those two different platforms. And again, that's often called out as one of those key strengths of Terraform. So as I said, the Terraform registry really is a brilliant place to start, particularly for the Azure RM, the Azure provider. Tells you what you need to do to use it, tells you what you need to do to authenticate, gives you a workable reference guide to all of the resources that you can actually build there. So one of the things just to cover off in the provider.tf file, and I will show this when we move to the code example, but actually you need to add those providers to Terraform by creating a file called provider.tf within VS Code and adding that provider information. If I just scroll back a second, you'll see that purple use provider box. If you press on that, it will give you all of the information that you need to paste in here. So again, it's very helpful. It builds that out for you. Just kind of perfect timing really with Alan's question. There are lots of other providers available. If you go on that link, registry.terraform.io, and hit browse/providers, there's absolutely loads. There are providers that are maintained by HashiCorp. There are third-party providers. There are community providers. There's a whole host of different things you can do. And it's worth calling out that some of those providers do things that perhaps you might be thinking, well, why does that need a provider? And one of the specific examples I would call out there is a provider called the random provider. And I use that in a lot of the code that I deploy because I like to add randomization. For example, during one of the first examples I was working with in Terraform, I hard-coded the name of a key vault. And you'll know that key vault names need to be unique in Azure, and actually then use that code with some colleagues just to do a bit of a demo and sort of show off what I'd learned. And the first person deployed it successfully, and the second person then said, oh, it's failing. And that was a really good example to me of how that provider helped solve a problem. I then built that random provider into the code, started using randomization in my naming, and just using that provider, I'm able to do things like, if 100 people go and deploy this example environment, they will all have a different key vault name. And things like that are added to Terraform by those providers. So it's certainly very powerful when you start using those. And there's things like HTTP provider. We can go and do a GET type request. We can interact with that sort of stuff. There are DNS providers. We've got a provider here. You can see for Active Directory as well. There's a whole host of things. So my recommendation would probably be that on day one, perhaps start with one, get comfortable with it, start building from there. But as you get more confident, start extending that and seeing what else you can do. And I think you'll soon find that the sort of the range of tasks you can carry out from Terraform is pretty expansive. So again, just a bit of just an example here. The AWS provider, again by HashiCorp, very similar. Full documentation, shows you how to use it, gives you examples. We'll talk to you about authentication. You can see just slightly further down the page under the example bit, just on the right, there's authentication. It's got all that kind of reference material that you need. This is a slightly old screenshot because the version's a little bit old now, I think, but you can see there's 1,271 resources available in that provider. So the reference material from HashiCorp and the supporting documentation is brilliant. Definitely something when you're on that learning journey, I'd recommend using just to help you out, really. Let's talk about process. Terraform code is typically arranged across a number of files called TF files, shockingly because they have the extension of .tf, but those are your Terraform files. And just a note on that, I've seen a few examples where people have kind of asked questions about this. Terraform doesn't mind if you have everything in one file or you have everything across 10 files. When you actually run Terraform, it will analyze all of those files as a group and build its execution plan. So the arrangement of those files is very much something that is sort of more for your sanity rather than keeping it all in one file. Perhaps you would have one for a particular virtual machine, another for your networking, another for a gateway, another for firewall rules. Think of it as that kind of arrangement. So those files define the infrastructure and the configuration, or any changes if we've made tweaks to them that we want Terraform to actually go and apply. At the time of running Terraform, those files are analyzed and they're turned into an execution plan where we can apply our changes. And this, again, is one of the real big strengths that Terraform has, because we can actually analyze change before we apply it. So there are 4 key things that we need to talk about, and those are the Terraform stages. Now, there are more stages than this. There are, validation stages. There are stages where we can run without any prompting, for example. But these are the kind of 4 you will need to get started and actually start working with Terraform. So when we first have a folder with code in or a repo, we need to actually initialize Terraform, and that's done by running Terraform space init. What that does is goes off and initializes the binaries, and it downloads the required providers based on what you've defined in your provider.tf file. So for example, if you said I'd like the Azure RM provider and I would like it to be, a certain version, that's what it will go off and download. If you've added 3 different providers, it will go off and download all of those. So that's really interesting as well, because we can version control those, and there are different versions of those providers as changes are made, as new features come out. So you can actually call out a specific version that you'd want Terraform to be using if necessary. Terraform plan is probably one of the most useful commands as well. So that stage will actually analyze and examine our TF, our Terraform files, and provide an overview of the changes and give us Terraform's execution plan. So the way this tends to get used is, let's say we have an environment that's running and we need to make a change to it. I get an email that says, Jake, I need you to change the IP address of this virtual machine and do that in Terraform, please. Well, I can go and make that change to the code file. I can then go and run Terraform plan, and Terraform will tell me I am going to change this IP address of this virtual machine, for example. And that's very useful because it provides you with that sort of safety net. Now, in the real world, if you were having a Terraform controlled environment that was production, large scale, you would probably have a test environment. You might run it there first and then move it to production. But plan just allows you to understand what is going to happen. Plan will not do anything to your environment. It will only tell you what Terraform's plan is. It will not apply any change. So it's a very useful sanity check when you're actually trying to run Terraform. Terraform Apply will carry out the execution plan and implement those changes. Now, it's worth calling out that Terraform Apply also will actually carry out a plan. It will tell you what it's going to do, and then it will ask you to confirm. Last but by no means least is Terraform Destroy. That does exactly what it says on the tin. It will destroy the infrastructure. But again, it will give you a plan output first, saying this is what I plan to do, and it will ask you to confirm that. I just got a question from D in the chat. So yes, you are correct. Terraform, the plan runs off the state file. Now, the state file is Terraform's working knowledge of what's been done. If there have been changes outside, the chances are you will get an error message. That's a really important point as well, because Terraform as a tool is very much something that you need to use. And changes in the portal, changes in Terraform as a mixture don't tend to work brilliantly. It's something that you need to, kind of go all or nothing in, really. So that was perfect timing with with your question, Dee. So the Terraform actually stores information about your infrastructure within a file known as the state file. The best way of thinking about that is imagine you've got a notepad on your desk and somebody says, please go and build me 3 VMs. And you go off and you write down, I'm going to build 3 VMs. The first one's called this, its IP address is that, and then you go and do it. That plan on the page, that document that you've written down, that is like the state file. So when you ask Terraform to run plans, it runs it against that state file. It's worth calling out the state file can be stored locally, and if you're just doing labs, testing, development, that's probably where you're going to store it. You don't need to worry about remote state or backing it up when it's just a test environment or your lab once you're learning. But actually in when you're using DevOps tooling or production environments, that state file is probably going to be stored remotely. In Terraform Cloud, it stores the state for you. In perhaps using Azure DevOps, you might put that in an Azure storage account, for example. But it's just something you need to consider, and the state file does need consideration and care. It needs to be looked after. Yeah, comment, sorry, from D saying, yep, that Alan and I aren't paid actors. The questions have worked out perfectly on timing here, so thank you. So just a bit of a diagram about ways of working. So this is kind of a local example. This is how I've deployed my lab environment, and this is where I'd recommend you start. Start on a single machine, fire up your laptop, your desktop, whatever it may be. Create and modify that code locally, save it into a local folder, run Terraform locally, allow it to compare to the state file, and then create your infrastructure that way. The benefit here is when this is new, when you're learning something new, you're only focused on the Terraform. You're not worrying about the pipeline, the remote repo, the remote state file, that sort of stuff. It allows you to focus entirely on the code, and this is definitely where I recommend starting. What you will start to find, and perhaps if you're looking at adopting this in a business, is it doesn't scale. The problem with this is, let's say, I'm building out a customer environment. I'm working on my machine. This is amazing. I'm getting loads of work done, and then, my laptop fails and I haven't got a backup of the code. Well, we're then in a position where we've got a deployment done for the customer, but we've got unrecoverable files. Now, there are ways to take an existing configuration and import that into Terraform. That's something that has come out in about the last year or 18 months or so, but it's not easy. You'd have to really work backwards, and it's going to cause you delays. So this works really well for lab and test environments and trying things out, but it doesn't scale to enterprise really. Perhaps a more remote example, and this is kind of the method I use for deploying my labs, because I don't really want anything on my device. I just want to save things into a remote repo, have a pipeline run it for me, and if I'm late to a meeting on a train, stressing about getting something deployed, the pipeline is doing that remotely. I'm not having to be connected on my laptop. I can trigger it and forget. And this approach is more like what you would see in a business. So, multiple people working on code creation and modification, saving it into a remote repo, perhaps GitHub, perhaps Azure DevOps, other platforms are available, and Terraform actually running in a pipeline, so being run in a remote execution environment with its state file in Azure storage. And that works nicely, because, one of these people could win the lottery, be sat on a desert island, decide, you know what, I'm not working anymore, I'm off, see ya, and it doesn't stop us. We have all the files remotely saved, so there's no risk there. We have our pipeline running remotely, and we have our state file somewhere safe in Azure storage. So this is a far more sort of enterprise example of how this would work and sort of scale from that very simple lab environment up to a much more remote example. And it's worth calling out, these people aren't always in the same place. So you might have a geographically diverse team spread all out across the world making changes. In this example, it might be multiple pipelines. It could be lots of different things running. And actually, using this method means there is no risk really. Somebody's device, if it fails, doesn't matter. If somebody leaves the company, we just close their account. Everybody's working in this remote fashion, saving code to remote repo. Terraform is running remotely, and we have our state file securely in Azure storage. So this is kind of the future state you will get to once you get beyond that initial learning journey. So let's talk about why you would use Terraform for Azure deployment. And this kind of this is very similar to the the kind of benefits of infrastructure as code, unsurprisingly. But it's really because you can create that infrastructure very easily, very repeatably, and in different locations, platforms, and regions. And there are lots of functions and ways of working in Terraform that really enable that. So, for example, one of the environments I've worked on uses map variables, and that map variable actually allows us to define a block per region that's then deployed in as many regions as we specify. So, for example, I could have on day one a block that says UK South and here's your IP address space, and on day two, I could add UK West and give it an IP address space, and it would go off and build that for me. And that kind of approach really allows you to scale quite quickly as you require. Rapid deployment and testing, that goes without saying. Actually being able to take production configuration, quickly deploy that perhaps in a lab or demo or testing environment to try perhaps you've got a change coming up and you want to test it. That is a huge win for using this type of approach. It's cost effective as well. There's a bit of a running joke amongst me and some of my colleagues. When I was awarded MVP, I got given some Azure credit that I use for helping me write blog posts, for testing out labs, for things like this. And I've struggled to spend it all because I'm using Terraform to do that. And I often find I deploy an environment as and when I need it, and then I destroy it once it's used. So the actual use is very, 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 very low. You can scale pretty much as you require. So up, down, in or out. That might be scaling up to have more in a certain region. It might be scaling down. You might be scaling out to other regions. Expansion is a key aspect as well. So I talked about some of those functions, but things like count. You can actually use count in Terraform to say, well, today I just need one VM, or I need one VNet to run this, and tomorrow I might like to increase that to 10. So there's lots of things you can do within those functions. My advice would be on day one, perhaps don't delve into the functions, get comfortable with just the basics first. But once you start to find you are getting comfortable, functions are very, very powerful in Terraform. Perhaps one of the key aspects, so version control of infrastructure. For a very long time, version controlling infrastructure was kind of a bit of a pipe dream, and actually being able to do that in Terraform is something that's very, very powerful. Going back to my example, working safely and in a standardized way across distributed teams, well, that is, again, a huge win for infrastructure as code. And write once, deploy many times. The lab environment I'm going to just go and show you some of the code from in a minute. I've used countless times for demos. Just see a few questions. So Alan, in response to your question, I've not used OpenTofu myself. I've stuck with the community version of Terraform, so I can't comment on that one, I'm afraid. So if you want to get started, actually, again, the HashiCorp documentation is brilliant, and their recommendation is actually to use Chocolatey, if anyone's familiar with that. But there's three things I'd recommend you have. One is Terraform. You won't get very far if that's not available for obvious reasons. Visual Studio Code as well is fantastic. It's a great IDE that you can use, but also use the extensions. It'll help with sort of syntax highlighting, completion, that sort of stuff. If you do want to use Chocolatey, those three commands: Choco install Terraform, Azure CLI, and VS Code will get you up and running nice and quickly. Lots about extensions, but there is an official HashiCorp Terraform extension as well. So IntelliSense, syntax validation, navigation, formatting, snippets, cloud integration. Well worth having that installed. Pretty much the #1 recommendation that I make whenever I see somebody working with Terraform and there's no highlighting. please get that installed because it will make your life easier. And it's just, you know, when you're learning something, all of those small things that make it easier are well worth doing. Something else I'd like to call out, if you have access or it's something you've been looking at doing, try GitHub Copilot. It's brilliant. You know, I did a very basic example here. I asked Terraform to create 2 public IPs in the UK South region and do that using the count function. I threw it a curveball. I didn't just ask for 2 blocks. Here's public IP number 1. Here's public IP number 2. I specifically asked it to use the count function, and you can actually see what it's done here is it's put count. So it's given me 1 resource block for the public IP. It's used count and it's put count index in the name, so it will iterate through that. And that's actually a really good example where GitHub Copilot can just help you on that learning journey. So, bit of time for some demo. You'll be very pleased to know I'm not going to deploy the demo and sit and run through it because we've just sat here watching code for about 25 minutes. But I'm just going to very briefly show you some of the files, just quickly show you what that's created. Then I'll share some resources and take any more questions. And what I'll do is I'll share a few links over the next couple of days, just online, you know, that will help you get started and that sort of stuff. So bear with me 2 seconds whilst I switch. Okay, hopefully you can see a nice VS Code window. So what I'm actually deploying is something called the Single Region Azure Base Lab v2. This is something I created. Bear with me 1 second. I'm just going to pop a link to that in the chat for you as well. If anybody would like to download this, you are more than welcome. It's in my GitHub, and there's also some information on it that explains what you would need to do. So I'll just paste that into the chat window for you as well. But essentially, this is a very small lab environment designed for those sort of scenarios where, certainly in my role, I encounter quite a lot. Can we test feature X? Can we try out Y? And what I need is almost a mini landing zone. So give me something that would allow me to run a domain controller, drop in Azure Firewall if I need it, have a VNet, have a hub and spoke, you know, do some basic testing. And it's helped me out in a lot of you know, a lot of those types of scenarios. And although it's fairly large, you know, there's quite a lot of code in this. I won't go through all this again. You'll be pleased to know. It's something I'd recommend starting with when you actually first start with Terraform. Start with some code perhaps somebody else has written and just have a go doing the deployment. Don't worry about writing your own code. Have a go doing a deploy, doing a plan, you know, doing a destroy, making some changes, and you'll start to kind of get confidence in the process, and then you can start moving on to your own code. So you'll see in this file there is a provider.tf. Again, I'm using 2 providers here. So I have Azure RM and I have random. I then have a number of files. So we'll leave core and optional for the moment, but we have a variables.tf, and this defines all of the variables that are in this particular Terraform deployment. And you'll see we've got core variables, they're strings, and we've got some optional features in this that are Boolean, so they're true or false. We then have a file known as terraform.tf vars. The best way to think of this is variables.tf defines the variables, and terraform.tf vars answers that question. So in variables, you are saying these are what the variables we need for this deployment, and in TF vars we are saying these are the variables for this deployment. So you'll see here I've given an environment tag of Jake Walsh 90 base lab v2. The region is UK South. I'm using a UKS. I'm just giving it a code to make the naming easier. I've got a CIDR range. So I'm actually using, in this particular example, again, I'm using a function within Terraform where it will take that /19 range and it will carve it up for me. I'm not doing any of the subnetting. Terraform is doing that for me. It's got a count, so it will build me however many VMs I put in this value, and it's got a few true or false items. So if I want Azure Bastion, I set that to true and I rerun the deployment. So this is just a kind of an example to use. You'll see in here there's a lot in this. So I won't go through the whole thing, but we've got some resource groups. We've got a key vault. Again, look, I'm using random here, so I'm actually generating a random ID for that key vault, and we've got things like a random password being created for the virtual machine. It's actually storing that password in a key vault. So I'm taking that randomly generated password, I'm popping it in the key vault, and later on in this code, I'm actually, the chances of me scrolling to the right place live is pretty slim, but we're actually pulling that information from the key vault and using that when we build the virtual machine. Perfect, there we go. So you'll see actually the admin password for the VM is actually a key vault secret called VM password that we created further up based on a randomly generated string. So that's a really good example of where you can build that security into Terraform just to just to kind of give that extra layer in your deployments. I could give this code to 100 people. 100 people could go off and deploy it. There would be 100 different unique key vault names, and there would be 100 different unique virtual machine passwords. And it would be the same, for example, if I destroyed it, deleted the state file, and then redid that deployment myself. So those sort of functions and those additional providers does allow you to extend that security aspect of Terraform quite significantly. As I said, I won't go through all this code because I'm pretty sure I'd have everyone asleep fairly quickly. But what I'm just going to do is give you a quick example of what this is built, and then my recommendation, if you are interested, would be go off and try it and build it. If you get any issues, feel free to reach out. I'm certainly happy to help. So bear with me a second. I'll just switch. Okay, so hopefully the Azure portal is showing now. So what this is actually built for me is 3 resource groups. The first one is connectivity. You can see here I've got NSGs for hub and spoke. I've got VNets, and you'll see in this hub VNet, this has actually been carved up for me. So it's taken that /19 and turned it into a /21. I've got some subnets in here. I believe they're /24s. Again, that carving up is done within that Terraform code. So you'll see me using the CIDR subnet function. I'm not actually having to do that. Terraform is doing that for me. So again, a very powerful example. You'll see in identity, it's created me an availability set. We've got a disk, we've got a network interface, public IP, we've got a virtual machine. And in the security one, we've got a key vault that's been created with its nice randomly generated ID. So a bit of a whistle-stop tour of what that code's created, but hopefully it just gives you an idea of what's possible within Terraform. I'll just switch back. So yeah, again, quite a whistle-stop demo. The only thing left really for me to say is any resources. I will put a post up with all of this information, and I'll paste this into the chat once I've finished presenting, just so you've got all that. But yeah, I've got some blog posts, some things you can do. The HashiCorp Learn Azure tutorial is brilliant as well. And those sample environments are there. They're in my GitHub repo. Those are available for anyone in the community. Do what you like with those. If you have challenges, any problems, please do feel free to reach out. That's what they're there for. They're there to help. I hope that was useful, and happy to take questions.
Amazing, Jake. Really, really good. Really clear, concise, great intro to Terraform. Really, really enjoyed that. Thanks so much for jumping in. Really good. I don't know if you managed to pick up all the questions. Did you?
I've just got
a couple of comments. Joe, one of the things I was going to ask you, Jake, I don't know how it's come along since I last looked, but there was, talking about state and being able to read state from Azure before you republish your state. I remember there was a module called Terrafy that would kind of reverse engineer your state.
Yes.
Where are we with things like that now, Jake, and Terraform? Are we any further forward, or?
There is. Bear with me 1 second. Interestingly, I was possibly the most excited person in the room when I went to Hashi Days last year, which if anybody's interested, Hashi Days is brilliant. The Hashi Days London was absolutely fantastic. But they actually announced the import feature in Terraform 1.5 there. And what that actually allows you to do is define a resource to be imported, and Terraform will then import it and bring that into your code. So that is originally it was kind of a community piece with Terrafy, I think. I'm pretty sure it was. But in terms of this, it actually brings that as a natively supported item within Terraform. So you can now take an existing environment, import it, and manage that using Terraform. So it is actually natively available now.
Okay, but that's like an import command. So that's you'd have to kind of relate it to the top level item, and what would it then discover? Anything that's attached to it? Like if you were to give it a VM, it would discover the network and the IP and things like that.
And you have to actually give it the resources you want to be imported. So it's okay. I think it's if for example you suddenly found out you'd lost your state file and you needed to import 100,000 resources, you're probably going to need a good pot of coffee and a fairly long evening. But it is there. It's still there as a feature, and it's something you can do.
It would be cool to see to see them do something like a scour, like you can point at a resource group and scour all the. That's a job for somebody. Scour all the objects and convert that into a Terraform import command would be quite an interesting one, wouldn't it?
Yeah.
That's a job for somebody.
It's certainly one of those, and I think when I talk to customers about the state file, we always put an emphasis on protecting the state file. It is sensitive. There is sensitive information in it. It needs to be treated as a sensitive resource, and it needs to be backed up. See it as like you would a configuration database for something. It's important. It contains live data, but there is the import feature is definitely there.
Oh, that's cool. Thanks, bud. Bro. I don't know if there's any more questions or anything else to anybody wants to ask.
I've got a couple of minutes.
Alan's
Alan's got one. Would Bicep be better?
And then, I think Simon's got his hand up as well in the chat.
The Bicep one is an interesting question, and the 0-day support is something that comes up. Now, there is something in Terraform called AZ API that allows you to embed JSON like you would for an ARM deployment, for example, in Terraform. But that is a debate people often have. And again, no state file with Bicep, so certainly something to consider. I think what I would say on that is specific use cases to be considered. So what are you doing in your deployment? Are there functions you need to use, or are you deploying to somewhere else as well? Sorry, Simon, did you say Simon had his hand up as well?
Oh, yeah. Great talk, really interesting. The CIDR split function. Say you had your VNet CIDR in one Terraform config with a state file, and then you needed to declare your subnets in a different config with a state file. Would it be able to break up CIDR? Like, will it know about the CIDR ranges between them, or does it all have to be in one config to do that?
So they could be in separate files. For sort of sanity reasons, or I would like my subnets and VNets for this function here, I'd like the other ones over here, for example. But if it's separate deployments, they wouldn't know about each other. So you'd have to play it sort of carefully with that, but there's no reason why you couldn't do that in a single deployment and have it doing clever things for you. I'll share a link for you, Simon, that's got some information about those functions, because there's CIDR subnet and CIDR host, and they're very, very handy when you just want to have a variable that defines a range and then carve that up as you need in your deployment.
Yeah, I'd not heard about that, but looks really, really useful. Thank you.
No worries. Cool. I think that's
any more for any more? Looks all good.
That's really good.
Sorry, boys, to cut in. This is Brad talking. I wrote a question in the chat around, I suppose, best practices. So when I've read a lot of people's code, no problem. When I've read a lot of people's code in the past, you can see everyone does things differently in regards to how much information they put into the main.tf file, how they separate resources. Like they'll have networking resources in one .tf file, they'll have storage in one .tf file. Is there any, I suppose, blogs or resources you could recommend which have like standardization? That's a word, or best practices?
There are. Some of the Microsoft modules are really good for that as well. Some of the community stuff that's out there. What my advice on that is your sanity is important. So don't suffer with one file with 10,000 lines in. If the split works for you of different files, it works. Terraform doesn't mind if it's 10 files, with 100 lines in, or one file with lots more in. But your ability to look at those and work out what goes where, be able to quickly make changes and identify what needs to be changed is the key factor there.
Yeah, that makes sense. I definitely prefer the large amount of files with the littlest amount of code.
Yeah.
I'd also recommend looking at something like TF-lint, where you could enforce rules on a project for everyone, so it becomes part of your CI/CD pipeline that before you actually deploy anything, you run a linting step. It checks to see whether or not you're compliant with your set of rules, and do it that way. The other one that's interesting in that space as well is Chekhov, which is like Chekhov. Chekhov.io, I think, is the website, and that's like a policy. It's like if you've ever seen Azure Policy and how it kind of enforces stuff in Azure, Chekhov does it almost before it deploys it, so it checks the Terraform to see whether or not what you're going to deploy is going to be compliant.
Okay, awesome. Thank you very much.
I'll drop some links in for them because they're useful.
Yeah, no, good stuff. Brilliant. Well, on that note then, Jake, really thank you so much again for giving up your time and coming on and
thank you
delivering a great talk as always. What is it? The React button? Are we doing the React or are we doing the off mute and clap? What are we doing these days?
Pick the bow.
There we go. We got it. No,
Thanks,
perfect,
everyone.
Jake.
Cheers.
As always, I appreciate you've got to drop off now for other things, but feel free to stick around and join in the quiz if you want to as well at the end. So
thank you.
We got a couple of ebooks and some vouchers. So we're building up our stock of prizes. We are. So thanks again, Jake. I will catch up with you soon, no doubt, buddy. Thank you.
Thanks, Jake.
Bye, everyone.
Thank you.
And on that note, we will hand straight over to our next speaker. So, Nara, I can see you waiting there with an absolutely wonderful background. I don't know why we've all decided to go for the same one, but
no, it works. You two started it. I followed. So.
Nara,
yeah, I had to.
Over to
Finally,
you,
I think
sir.
I have some light in the room. Can you hear me?
Yeah, got you loud and clear, and can see your screen as well.
Okay, you can see the screen. Great, thank you. So yeah, I'm Narayanan Subramanian. I work as a senior solution architect here at Sempris. I'm located at Bentonville, Arkansas, and I have a Medium account as well, medium.com/@nano. I'll paste some of those when we are about to end the presentation, so you can look at some of the blogs that I do. I usually blog on, Active Directory, Entra, GCP, and all those things. And I like how more about directories and how to manage directories using automated functions, credentials, managed identities, and good that we today started off with Terraform. And with Terraform, what I saw is that that's something that I want to research into, like deploying workload identity federation with Terraform. So that'll be an interesting one. But for now, let's look at what is workload identity federation. So most of you all must be knowing it's kind of the hot topic that goes around nowadays. A lot of people building, with these built-in connectors for GitHub and other stuff for workload identity federation. I just wanted to point out kind of different ways in which we can use workload identity federation, things that, at normal day-to-day admin activities, or if you are using multiple cloud providers and you want to kind of manage something from a cloud provider that you really like. Sometimes, as an example, is Google Cloud Platform. And if you have used Google Cloud Functions and things, you would see that some of them don't have support for PowerShell. So in that case, you have to kind of learn Python or something like that to start deploying code and running things against another cloud provider. So that exact issue is what got me into digging into workload identity federation. So basically what it is a system that allows workloads to access resources across cloud platforms without the need for credentials and secrets. So as we all know, we work a lot with Azure Key Vault, storing credentials and secrets for our applications to consume and retrieve them, and then we got to worry about ACLing them, finding that the right people have access to it or not, and manage all those resources and everything. So workload identity federation kind of gives you that ability to go credentialless, like passwordless is the new term today. So this is more for applications where you can kind of go without requiring any credentials or secrets that you need to manage, kind of helps in that particular fashion. Okay, like I mentioned, what are some of the features that come with it? Like one is eliminate credentials. Basically, you are trying to impersonate tokens or exchange tokens in a sense that only one identity provider in one cloud can talk to another identity provider in another cloud, like an app registration service principal or managed identity. And we'll come to terms like in Google Cloud, like things like Google Service Account and Google Managed Service Accounts. And also what this helps with is like, I see the future kind of going towards multi-cloud and management, because of costs and several other things. Companies might be moving into things like vendor locking. I want to avoid vendor lock-in. Like Microsoft doesn't give me something, I want to use something in Google which may be much cheaper, or if Google's not giving me something which is going to come out maybe 2 years later, and Microsoft is giving me something, I want to balance that a particular issue, right? Like what I would get from all these different cloud providers. And what happens is that companies will end up with 2 or 3 clouds. And if I want to seamlessly manage my applications across both of these, in my case as an admin, it would be more of directories and users and managing all of them. I would want easier ways to script things against it. So that's what I think this really helps. The other inherent feature is short-lived tokens. So whenever you get tokens out of these workload identity federation token exchange, which we will come into, usually it's 1 hour, but there are caveats, and we will look into those caveats and things where things don't actually turn out to be true. It's not 1 hour. Sometimes it's configurable, sometimes it's not configurable, and sometimes you will see that they are much more longer than what you expect. Token chaining. So token chaining is also something that is possible with Workload Identity Federation. It's like if you go into the Google Cloud Workload Identity Federation pages, you'll start seeing things like, how do I integrate Active Directory integrated applications like a GMSA or something running for applications, and exchange tokens against Google Cloud. And then with those tokens, you can kind of exchange it again with another cloud, or you can even go from Active Directory to ADFS and get your token with ADFS after a token exchange, and then you go back again against GCP. So you get into this scenario where you can kind of chain these tokens indefinitely if you want, but of course, nobody wants to do that, right? But still, it is possible. So where does that take us? So a lot of questions and challenges that come with it. Again, like I mentioned, activity tracing. If somebody is configuring things like this against multiple clouds or identity providers and things like that, where do you start tracing this? What is the origin, or where is it's failing, and things like that. Analyzing privileges, again, it's going to be tough, because now between various cloud providers, how do you look at an identity, like for example, a service principal in Azure, and say that, oh, it doesn't have any permissions, when it might be having VM deploy permissions in Google Cloud? How do you analyze privileges in a way that is coherent with multiple cloud providers? Again, access path mapping becomes difficult. Again, what kind of accesses each of these service principals or any other managed identities or Google service account has, and how do you map access to certain tiers? Do they have access to this tier in this cloud provider? Do they not have it? And of course, along with that, you bring in this complexity, and you have to start managing this complexity. And yeah, feel free to stop me wherever if you have any questions. But now, again, this is how to impersonate a service account in GCP, for instance. You have an on-prem or other cloud applications here. Like you have a workload running in Entra, for example. We can take Entra as the workload here, an Azure function. And how do you access a Google Cloud application here? So in Google Cloud, you need to have a GCP resource for sure. You need to enable the APIs such as Workload Identity Pool. So Workload Identity Pool is a service that you need to enable in your Google subscription, where it's called a project. So in Google, the Google subscription is not the right word. So it's a Google project. So in your project, you have the ability to enable these APIs, security token service and Workload Identity Pool. So in a nutshell, how this works is that, the workload running in, for example, Entra, my function app has an identity, and it can generate a token for that identity. I can exchange that ID token against the security token service in my workload identity pool in my Google project. And then after the exchange, what I do get is a token that Google can understand. So here the main part is, what is the security token service is doing is that, because Google can't understand the tokens that Azure uses and different cloud providers uses, it acts as a translation service to kind of give you that token that Google can understand. And then in my workload identity pool, what I do set up is certain mappings in such a way that whatever is coming and that is allowed into my workload identity pool, only that identity is allowed to generate a token for the service account in my Google project. So that is the main reason where we have to kind of segregate the access in such a way that that access is only given to that particular identity which is coming into our pool. Does that mean the identity in Azure is equal to the identity in the Google project that you have? Not exactly. But then again, it's kind of an impersonation where it kind of allows you to go generate tokens for it. And once you get a token for a Google service account in your project and whatever permissions you have given within your project for that service account, you can start doing whatever activities you want within Google Cloud. And we'll look at some of the examples as well. There's like 3 demos if the demo gods, help us and it works fine. Now, this again is the opposite. This is from another blog, Identity Digest, where they talk about how do you impersonate an Azure service principal. Now, if you're sitting in Google, so in Google, you can kind of have a Google service account or a Google managed service account, which is similar to an Azure managed identity. And you get your ID token, you exchange it against an Azure STS endpoint to get a token which Azure understands. And then you set up the workload identity federation on, I think stop. Okay, yeah, you can kind of create that workload identity federation mapping on your Azure service principal. So it only allows that particular identity which comes from Google, and it can generate a token for that service principal and then do the things in Azure that you want. Or you can even go from Azure, exchange that token against Entra. So connect MG graph. What does that do with the managed identities token? It converts it into something that you can use against Entra and start doing listing users, managing users, whatever you want to do in Entra. So we'll look at how we do this through the demos. Oh yeah, and to quickly point out here, you can see that there's an audience here that's mentioned Azure AD Token Exchange. That's the audience that you specify when you want to generate the ID token. So that this audience is what mainly is responsible, which the configuration on your workload entity, configuration on your service principal looks for this audience. Like if you have any other audience which is not allowed, then you are kind of blocked from accessing it, or it's going to give you an error saying that the audience that you have used is incorrect. And okay, so now we can kind of quickly look at how we can eliminate the need for these secrets. So I've got like 3 demos here showing all those 2 scenarios that I mentioned. One is accessing Azure from a Google environment. One is accessing Google from an Azure environment, and also that the one where we access Google, GCP, Google Cloud Platform from an Azure function app or something. What I've also done is there is something that I've discovered recently, which I worked with Google on a case, which was actually accessing Google Workspace, which is a totally different subscription, right? Like, for Office 365, you have something different. Now that's the equivalent for Google Workspace, Gmail, the Google directory and everything. So you can even access that through workload identity federation, and that kind of opens up some unintended consequences that we can speak about. My discussions with the Google project teams and others, where that, they may fix the bug in the future, but they don't call it a bug, but it's kind of an unintended access that has really happened. Just to go through this again, we have Google Workspace. Some of the terminologies that's being used in this presentation, Google Workspace, like I mentioned, is the email and Gmail directory and other services that is configured on the Google side. Google Project, kind of think it's kind of like a resource group in Azure. Workload identity pool is more like a service that you enable on the Google project that you have. It can also be a service that can be enabled at the org level, which is a different concept in Google, but you can actually enable it in a service level on your Google project. So basically, you're enabling it on your resource. And one thing I forgot to mention was, now with these different cloud providers that we have, there are cases where you will see that why they are different. Like Azure to Azure, Microsoft says you cannot federate within your own tenant or with another Azure tenant. That is blocked by default. And there's a particular error message that you will get if you try to federate between Azure to Azure. I'm not talking about something like an AKS exchanging tokens against Azure. This is more Azure app registration to another app registration, which is service principal to service principal. You cannot do that. So one of my third demos is going to be like, if you worked on Active Directory long enough, you would know that trusts are there, and workload identity federation is nothing. It's not similar to trust, but still it has so many inherent features of a trust, where A trusts B, B trusts C, then A trusts C. So you can kind of get into a scenario where a service principal in Azure trusts a Google application or a service account, and that service account trusts back and managed identity in Azure on your own tenant. Then you can kind of have a path wherein you can kind of authenticate through token chaining and come back to your own tenant into a different app registration. What kind of can opens up, I don't know, but it is possible. But as everyone knows, complexity kind of breeds a lot of insecurity and things like that. But I thought it was just interesting to kind of showcase how those things really work. And then we speak about metadata URI, which is the URI that is present in your serverless applications or VMs or anything, where you can kind of hit the endpoint to get a system assigned managed identity token or a user assigned managed identity token. If you have deployed serverless functions or VMs in Azure or Google, they have different metadata URI endpoints, which from within the resource only, you can hit them and get an access token, ID token for it. And then that ID token can be used for other activities based on whatever permissions you have kind of provided. So that's important here as well. And we can kind of see like how some of these service principals and managed identities can be accessed from different clouds. You would think that that's only accessible from a particular VM, but how do you get those privileges of a managed identity from external clouds and other resources? And then there's system assigned managed identity, user assigned managed identity. In my examples, I've used both to kind of showcase the difference. But just in a nutshell, system assigned managed identity, there is no support for workload identity federation configurations within them. So you can't create federated credentials on a system assigned managed identity. User assigned managed identities have support for federated credentials that in a way that you can go and configure what kind of issuer and things that you trust. And you can even put the globally unique identities over there. And we look at all of that in some of the demos. Okay. Okay, let me try to start the first demo, which is accessing some of these Google resources from Azure. And I didn't look if there was any questions. And the challenge is for Entra workload identity federation, Entra issues aren't supported. I guess what you mean like Entra to Entra, but yeah, that's a great idea, like what you mentioned. Like, but there are ways in which that's exactly what I was working on for a long time to figure out how, if I can't do from Entra to Entra, why can't I use a middleman like GCP, go to GCP and come back to Entra? I mean, that's a different way of solving the challenge, I guess, but I don't know how good that is or not, but it introduces a lot of can of worms. And then I'm sure SOC analysts and security administrators kind of have a hard time trying to figure out what is really happening over there. But let's quickly get into my demo. Let me share my screen here. Do you see my screen?
Yeah, got you.
Okay, cool. Okay, so here's one example of a function that I have in my Azure intratenant or Azure resource. So I called it Narafunc, and here is where I enable a system assigned managed identity into my Azure function. So basically what I did here is like I associated this identity to my function in such a way that now once I did this, I could go into managed identities or enterprise applications, and I can see that, this is actually become a service principal in my tenant for this function app. So there is an identity for it. Also, what this allows me right now is that this identity can now, this function can now retrieve its ID token from its metadata URI endpoint. And let me show you what happens in my code. So that way it's much more easier. So yeah, so if you can see here, I've given the scope as management.azure.com, and my URI is actually environment identity endpoint. I don't want to get into all the details of how this is being done, but these are like, basic Azure functions. You get an environmental variables by default when you set it up, but it will be using this endpoint, or you can use the entire URI itself over here. But I prefer to use the environmental variable itself to kind of get my metadata URI. So hitting this URL with these headers gets me an access token or ID token for my identity. Now, what really happens is that using this access token, I can exchange it against my Google Projects service account in such a way that I can get, an access token for, or an STS token. So this is the STS token that I get from my Google project where I've configured it. So let me quickly show you that. So this is my project in Google, and I don't want to get into all the details over here, but most of this is in my blogging that I did, because it takes a lot of time to set up each of these projects and then create all these service accounts and things like that. But in a nutshell, it's basically a workload identity federation pool. So if I look at a workload identity federation in my Google project, if it opens up, let me see. Okay, so here is my workload identity pool that I've generated. And if you look at this particular workload identity pool, and I'll take it a little bit slow so you can look at this workload identity pool. And what this is actually the tenant ID. So I'm basically saying that, when the issuer is the allowed issuer is one of these tenant IDs. So that is the tenant ID of the Azure function app that I've been using. So when it has an audience of management.azure.com, allow it into my workload identity pool. Basically, it gives you access into my workload identity pool in Google. Now, what that does is I can now, once it has access to the workload identity pool, it can generate token for the service account in my project. So like you've seen here, I've created several service accounts in my project here, and I'm using one of the service accounts with whatever rights. It doesn't matter what rights it has. Maybe it can create GCP VMs, it can create other things. But I've given that permission out so that it can do those tasks. But I could generate a token for that service account using this workload identity federation configuration. Again, like I mentioned, more details on how to set all these up through command line and code is available in my Medium blog. It takes a lot of time to set up, but one day I'm hoping, like the previous session, that I can use Terraform and managed identity to deploy all of that, which will make it much more easier. But here, let's come back here. So if you see here, like I got an access token or ID token for my Azure function app, and then I'm using that particular access token for performing a token exchange. So here I'm doing a token exchange with my access token against the STS endpoint for Google. So this gives a token that Google can understand now, and which has all the parameters that the Google service account can understand when I'm asking for it to give me a token for it. And let me see if there was any questions so far. That's a good point. Yeah, complexity, security risks. I mean, there's a lot of factors at play here. And what you find is that, in overprivileged environments, some developers may start configuring all of this. And as a security admin or something for your environment, you find it very difficult to trace all these activities and really figure out what is actually happening, which is where, I didn't use all of those. In this examples, I didn't use the built-in GitHub connector and things like that, which make it much more easier for us. This is just to show that, by raw code that, you can do all these things. And there are many unintended consequences that come out of it. So just to get back on track, here's my SGS token. And I will run this also to show how each of that looks. Now with this SGS token, I can generate a service account for my Google managed service, Google service account. So if you see here, this workload ID at project, this is my Google service account, and I'm using a generate access token function. So if I'm doing that, I can get a token for it. All that Google service account is looking at is like, is this workload identity pool impersonation account allowed to generate token? Yeah, he manages this object ID or app ID. It comes from this tenant. That is all good. Let me generate this token for you. Now, here's the other thing, which Google didn't, I guess, expect, or they've never documented this, or what came out of my research issue with them, is that you can use this token to pivot back into Google Workspace. Ideally, till 2020, you could only access Google Workspace from a GCP service account if you had something known as domain-wide delegation, which is basically an impersonation of an account, a user in your Google Cloud Identity workspace. Just to quickly show you, this is how Google Workspace looks. So you can see here that this is my Google Workspace. I have some users in my directory. And if I had to kind of list users in my directory before using a service account in running in GCP, the only way to do that was using something known as domain-wide delegation. And you can see that it's configured over here. If you look here, developers can register their apps with Google to access services in services like Gmail. So this was the old way of kind of giving consent and then allowing your service account in Google to come back and do things in your Google identity. And 2020, Google changed this by allowing some of the built-in roles in Google, where you can kind of have these admin roles, and you can see that certain roles are not eligible. But if you look here, let's take, for example, user management admin. And if I take a user management admin role, you can see that you can now assign service accounts to this role. This was brought out later. So what this actually does is that now that I have a service account in my Google project and it's been added to this particular role, it auto gets these APIs into its scope whenever I am generating an access token for it. I don't need to go and say that, give me this token or give me this privilege or that privilege. It gets auto injected in the backend. And because there's a translation service that sits between GCP and Google Workspace. I don't know all the hidden fundamentals behind it, but that's how it's almost working, where it kind of gives you those permissions out. Now just coming back into my function. So let me run the whole thing to show you what really happens. Unless my access token is expired, it's expired. So Okay, so just in a quick sample, I can list all of the users in my Google Identity Workspace from an Azure function sitting in my Azure tenant. That's what, I mean, that was my end goal. Like, I didn't want to write, PowerShell scripts with a service account and credentials or anything. I wanted to do things with a managed identity, and that too a system assigned managed identity to my serverless app. That way I can generate reports like Google Workspace or even GCP. I can start managing GCP over here, right? Like I can create VMs, delete VMs, whatever, actions that I want to do without credentials. And that was the end goal. And that's how this all works out, with the unintended consequence of kind of having access to the Google Workspace, which comes through that particular change that Google had made. But yeah, any questions on that? If not, let's go to the next one. Let me share. If you see my screen, this is like accessing Azure sitting in Google. Now, let me show you some quick examples on this. Just hold on 1 second. Okay, this is better. Now I have a managed identity here in my Azure tenant. And if I go to my managed identity, we have the option called federated credentials. Now, if you look here, what I've done here is that I have configured a federation towards with Google in such a way that whenever the issuer for Google matches this and the subject identifier. Now, this is a problem I can explain because this is the globally unique ID for the service account in Google. There is no tenant identifier for Google like what you saw in my workload identity pool configuration here. So if I go to my Google side, you can, if you look at my configuration, I have option to specify the tenant ID. Now, if you look at my Azure side configuration, you can see that there's no tenant ID or anything. All Google projects and all Google tenants have globally unique identifiers for their service accounts. Looking at this, like if an app developer has access to create credentials or federated credentials on your managed identity or even your app registration, how do you prevent kind of them, hey, you should be only talking to this Google org, or you should not be talking to another Google org? You can't. So that's one major problem right now. I'm thinking Google is trying to fix that. I don't know when or what is an ETA on it, but they are trying to find out some ways, John, how to fix that. But basically here what I'm saying is that if you say this globally unique identifier, then you are allowed to federate with this managed identity. Now, what would we think? This is a user assigned managed identity. In this case, it's not a system assigned managed identity. So I haven't assigned it to any resources nor given it anything on any permissions on any resource. All I've done is I've given it some app role assignments with the Entra API scopes such as directory read, write, all. So let's take a quick look at this example here. So this is a GCP VM. So Google Cloud Platform, I have a VM and I'm hitting the endpoint for metadata URI endpoint, which like we spoke about, gives you the access token. And I'm specifying my audience as Azure AD Token Exchange. Now, if I run this, what do I get? I get a token for this particular Google service account, which has been linked to this Google Cloud Platform VM. Don't think anything related to Azure right now because it's only a ID token for the Google service account. Now, next, what I'm doing is that I'm using the client credentials flow to kind of get an access token for the managed identity we spoke about. Now, if I run this and I get this token, and let's look at the access token over here and connect it with mg graph. And if I get mg context, what we get? Oh, so now I have an access token as the managed identity sitting in my Azure tenant from a GCP VM with the scope of directory read, write, all. So now you can imagine what I can do with against my Azure tenant sitting over here. And I could start, if I had more scopes such as users and any other kind of elevated scopes, I can start doing changes to my Azure tenant, and all of this without credentials. I hope that made sense. But yes, yeah, here I'm doing an example of searching users now with this access token, and I'm just selecting some users and displaying them. But then again, this makes my life easier if I know what I'm really doing. And in a sense that I can start, if I have a GCP VM, I can use it as a toolbox. If I have, I don't need to use Google functions, right? Or Google Cloud functions, which only support Python. And this may be an alternative way for me if I'm only supposed to work from GCP. And I can kind of use that managed identity. But if you look at that managed identity, unless you look at those federated credentials configuration, you wouldn't know if something else is having access to it. Now, here's the other thing, like I mentioned, looking at that globally unique ID. If I come back to my Google project here, and let's look at the service accounts. And here's my service account, and here's the auth to client ID or the globally unique ID, right? This globally unique ID, you cannot just look at it from an Azure tenant and say that it's coming from this particular Google tenant or Google org or some other Google org, which is a problem. Again, you will be like left wondering, how do I figure out? Let me search all of my companies' Google organizations to kind of make that determination that this is actually allowed. Or if some attacker has configured something where this was possible due to some other elevated privileges in Azure, then they can kind of take advantage of this. And you have to kind of monitor all of these workload identity federation creations on your resources. Coming to that, again, Azure policy has some options today where you can kind of restrict creation of federated credentials. You can kind of look at that to kind of restrict anybody coming and creating these federated credentials into your managed identities or anything. Coming to app registrations, I've not seen an option at all, because app registrations can also have this particular configuration. So if I go to my app registrations, if I take one of these app registration, certificate, secret, federated credentials, if I have these permissions, I can go add my own other issuer, and I can put https accounts.google.com or whatever you want to go put it over here, impersonating this particular service principal for this particular app registration. If there's no questions, we can go to the next example. Okay, so like one of those questions in the chat was like, because of the complexity and the security fear or whatever, we didn't go ahead with this. We didn't use this. Yes, there are some other things you can do with this. Like in this example, I'm kind of showing you like how I can use the system assigned managed identity in my Azure tenant to go into and impersonate a service account in Google and use the token in Google to come back to another app registration in my same Azure tenant. So you kind of did a U-turn and come back. So for this, what I do is like, I go back to my function app, I run this function. Now in my function, I can see that there's the STS token over here that I can use. I can copy this STS token for my Azure function, and I can use this STS token as the starting point to do this kind of a token exchange or a token chain. For some reason, it's not scrolling. Okay, now with this STS token, all I'm doing is that I'm generating an ID token for the Google service account. You can see here, the Google service account is mentioned here. I'm generating an ID token. And did that work? Yes, I got an ID token. Now using client credential flow, again, I'm trying to generate an access token and do whatever we did earlier. And you can see that I've become a managed identity back again with directory read write all. And if I do get mg user, there it is. I can get all of the users again. So what did we start with over here? If you were confused, we started with a STS token of my system assigned managed identity assigned to my Azure function app. I used it to generate an ID token with Azure ID Token Exchange as the audience for my Google service account. Using this Google service account, I refederated back to a managed identity in my Azure tenant. So basically, does that mean the system assigned managed identity for my Azure function has the same privilege as the managed identity? But you can get into these kind of access paths and confusions, and that's why it's very important to kind of not use this without understanding fully what really happens in the backend. Now, like, you may have apps which are federating with various built-in connectors that Microsoft provides and other things. But if you are not careful, you can get into a sprawl where other attack paths are being formed. But let me show you one more. And I'll share some of this code as well in some of the blogs that I have too. But you can always take these access tokens and put them into JWT-IO and decode them, and you can kind of look at these and see, like, what's really happening. Am I really my managed identity right now? But you can look over here, the app display name shows up over there, the app ID shows up over here, the roles show up over here. So you can do all of these things and kind of get a feel of what exactly is the audience and how the audience is actually changing when the exchange really happens. And then let's come back to the presentation. Okay, just to recap quickly, what we did, we used an Azure function with the system assigned managed identity initially. We had a GCP project, Google Workspace, everything configured, and then we implemented the workload identity federation APIs to be enabled in my project. And finally, with some scripts, we were able to kind of impersonate that particular service account in the Google project, which was simple, right? Like, one-to-one mapping. You went from a system assigned managed identity in a function, and you were able to do tasks in GCP. And then we did the reverse, which is using a GCP VM with an identity assigned to it. So you can assign identities like service accounts in your project in Google and assign them to your VMs. And that way it becomes the identity of the VM. And then whatever you can perform from within the VM, you could call the metadata URI and start getting those ID tokens. So with that, what we did is, like, we accessed Azure resources from a GCP VM with the metadata identity that we called through our script. And the third one is where we kind of went a little bit into the complexity weights. Like, we went from a system assigned managed identity in Azure function. We went into a Google project. We created an ID token for a Google service account. And then using the workload identity configuration, we came back to an app registration in the Entra tenant. Or in our case, what we did was we did it against a managed identity, which is different. Not the system assigned identity, but we came into a user assigned identity. And that user assigned identity had certain app roles assigned to it, like directory read write all, but it wasn't assigned to any VM or any resources, but still we could kind of use it to do whatever we want. So we kind of did that kind of a U-turn. I know there's a lot of things over here, and frankly, even I don't know, I'm still writing down like what other permutation combinations I can try. I'm not that comfortable with AWS yet, but AWS, Okta, and all these other providers, they all have some kind of support, for workload identities, even Active Directory to Google. So there are many other paths that are possible, but these are all intended to make the developers and applications administrators, life easier. So we may see more and more research and things coming into it in the future. So it's a good idea to kind of see what all this can do and look at it with a close eye. Like coming to Google, it's always good to kind of use unique attribute conditions. So basically, what this means is that, hey, if app ID of what's coming into Google is matching this ID, then allow it to kind of, impersonate your Google service account. Again, immutable attributes, don't use attributes such as display name, or other things, even though it's possible. Again, that gives you the attacker or a misconfiguration, anybody a path to kind of use those additional privileges that your service account may have in Google. So kind of avoid that. There's an org policy available in Google where you can restrict what kind of tenants are allowed. Like, for example, from AWS, only these tenant or orgs are allowed, or from Azure, only these tenants are allowed to federate with my Google org. So you can kind of set up these policies in advance to kind of block any malicious kind of configurations from even existing. Coming to Entra and Azure again, avoid elevated permissions on your app role assignments for your managed identities. Of course, goes without saying, don't use elevated permissions such as app role assignment, read write all, and many other kind of permissions that can give an access back into your Entra tenant and cause kind of other malicious attacks. Same way for Azure permissions, again, the same thing. Do not give any high elevated permissions across your subscription and things like that for a managed identity, and then federate these kind of things. You can even block the federated credentials using Azure policy in your resource groups or subscriptions. So you can kind of look at that as well to kind of determine how I do not want anybody to configure these unless there is a business requirement coming up, and kind of take a closer look at that time. But that's essentially it. Any other questions? I know there was a lot of content and there was a lot of things that you can find out from my blog as well. I will share that over here. But there are several other blogs showing some of those Google configurations that I had to go set up, but play around with this. I'm not an MVP, so it cost me a lot of money to kind of test all these things. I had to build out my Google Workspace, GCP, and Azure, and different tenants and everything. But yeah, let me know if you have any questions.
No, that was amazing, Nara. Thanks so much for talking through that. I think, certainly it's not one of my strong points, I must admit, when it comes to security, but certainly a whole heap of learnings from that for me personally. So, huge thanks for kind of stepping it through. I think it's one of those things, isn't it? Like you say, some of the nuances behind what we can and can't do natively with federation between tenants, like you say, but it's interesting to see the back doors, if they want to call them that, or what do they say, a bug?
They called it a bug, but it's not a bug. That's what they said. It's a bug, but we'll fix it, but it's not a bug.
That was between Google Workspaces use it, right? Okay, yeah. So it's no, but it's really kind of, I think as more and more customers are getting more savvy with workloads running in multi-cloud and on-prem and private data centers, certainly this kind of technique. However, it kind of comes out the de facto of, you know, IDPs versus how do we actually have a common way to access using, as you know, an IDP. And right, there's a few things that could come of it. So it's great to see how you've kind of tweaked that. So it's definitely one I'm going to be rewinding back through and having a look at some of those PowerShell scripts. Did you happen to have a repo, or is that all in your blog, Nara?
It's in my blog. It's kind of segregated, but it's not the whole scripts as such. But I'm trying to kind of, you know, change it into a format where it doesn't have my tenant ID and other things, so that you know, that way people can consume it. I've not yet got the time because I was so busy in that third demo that I did, which was more like, you know, I was trying to say, like, Microsoft says you can't do it between Azure tenants, and I was like, no, you can kind of go in between, use some middleman and come back. And I was playing with that. So once I'm done, you know, I can kind of share all of that. And
that's amazing.
And,
that's really
and
good.
I have more research to do in terms of, like, you know, now we have the graph activity logs come in and Azure AD managed identity logs. How do you write out KQL to figure out some of these things as a defender or as a SOC analyst? You know, you look at all these things and all this traffic going here and there in an environment, you don't know what is right, what is wrong. So that'll be a good second part, I guess, to dig into from a security perspective.
Oh, 100%. I think that's, you know, it's a really kind of interesting area to delve into, like you say, you know, with a security angle on, and, you know, being able to kind of track some of those metrics and signals through, you know, even, you know, from a Sentinel perspective, you know, even if it's a SOC piece, then trying to track some of those through and understand what a great kind of set of KQL, you know, kind of alerts or alerting on those kind of signals might look like. It's all massive value. So I don't know if there's anybody that's got any other specific questions, but for me, that was a fantastic talk. Thanks again, Nara.
No, I've got an observation actually, to combine both yours and Jake's talk actually, is that the Terraform provider, certainly in Azure DevOps and in GitHub, supports using Workload Identity Federation into Azure. So you can actually combine both of the talks from tonight into one thing. And it works really well, because it means that you don't have any secrets floating around anywhere. It's just brilliant.
Oh, yeah, exactly. And I know of some people actually using Terraform to deploy some of these workload identity federations into multiple clouds because of the agnostic nature of Terraform. But that's like, it just opens up so much different things that you can think about.
Yeah, absolutely.
No, brilliant. Cool. Well, look, if there's no more questions, if we can do Nara the good service of thanking him for his session, as always. You know, real privilege to have you on the session tonight, Nara. And like you say, maybe when you got the second half to your blog post get written up, we'll definitely get you back on, because that's really insightful. So thanks for your time, Nara.
Oh, good. Yeah, thank you. Yeah, do let me know any questions, and, you know, reach out to me if anything is there. Thank you so much.
No, brilliant. And like I said before, feel free to stick around now if you want to grab an Amazon voucher. It would be interesting to see how many questions OpenAI's generated, Matt. I
left out because OpenAI, it was a bit it was a bit woolly on some of the questions tonight. So these are all Matt generated.
Cool. So over to you then, Mr. Fatunka. Like I say, we've got quite a few prizes up for grabs this month. So I think we've got a fair decent amount still in the chat. So let's see if we can get everybody in. And I reckon we've got prizes 1 to 4, Matt. You reckon?
I hope so. Yeah, it's a good turn.
So we've got. So what we'll do is everybody sign on. We've got £25 Amazon gift vouchers for first and second place, and we'll do the CI/CD book for third place and the IoT book for fourth place. Sounds reasonable.
Yep, I think that's great.
There we are. I'm going to join in for fun, see how many I get wrong, so Matt can track me back afterwards.
Good set tonight, I think.
Yeah. Let me get in.
There are two subjects I'm interested in that the speakers have done tonight. So it's an interesting set of questions based on stuff that I'm actively working with at the time anyway. So
it's always nice having that refresh on Terraform, I think. So like I I was using it a hell of a lot. Then I changed roles. Didn't you? Well, not really used it since I've been at Microsoft. So it's always nice to go back, for those pet projects and just think, oh yeah, here we go. Because when certainly when you haven't used.
And I would say for anyone that wants to speak at the user groups, don't be afraid to cover basic stuff.
Yeah.
Because I've been using Terraform for a couple of years now, and there was still stuff I learned tonight. I was like the side arrange stuff. I was like, yep,
yeah,
okay, that's really useful. I'm going to use that now. Didn't know that existed. That's really handy.
That's the beauty, isn't it? That's the beauty, like you say. Sometimes you can overlook. You've got to think, I got to get on and complicated it to hell. And at the end of the day, no, it's he's surprised how much a basic talk. And I always love getting back to basics, to be honest.
Yeah, I agree.
My always first point. If ever there's something new or something I need to I'll make sure start from scratch. Because you always miss something.
Yeah.
But
is anyone having problems getting in? Otherwise, we'll kick it off.
How are we looking? We've got potentially. Yeah, no worries, Jim. So there's Jim is out, so that's and you.
Who's trying to break my system with putting emojis in their name?
Oh, look at that. Who is that? What is that? A lightning bolt?
Must be D.
No, I thought I saw D. Oh no, that's what he's done, isn't it? I thought he joined. Is he rejoined? He's rejoined, haven't he? I saw him with D. He's a security guy, remember, Matt? You've got to watch these folks.
Couple more seconds and then we'll kick on.
Yeah. Yeah, we're a few short. If you are struggling, shout in the chat now if you're struggling to get on for whatever reason. Otherwise, probably 2 or 3 people out there, unless people have just.
Oh, defo not me from D on that. I never know.
I thought I saw D's name go up, but I can't see it there now.
Really D?
Yeah, he's script alert. There we go. He knows. Brilliant.
Right, I'm going to start this off. Otherwise, so apologies if you can't get in.
Good chance of a prize tonight. Then first 4 winners. So.
Yep. Okay. Which Terraform command shows a list of changes that will be made? Easy one to start with. Terraform plan, yes, everyone got that one. Which of the scenarios does not work with Workload Identity Federation?
Ooh.
At least not easily. I'll add a caveat on there.
I'm going to go for something contentious.
I'm
going to go. No, I got it wrong.
No.
I was going to go Jira, and I thought, oh, let me wonder. It's one of those GitHub ones.
What's the name of the module for deploying Azure resources in Terraform? Now, we mentioned 2 tonight. This is the original one, the one that HashiCorp maintained, I think. It's Azure RM. Yep, a lot of good answers tonight. If I want to run Terraform in an Azure pipeline, what even does that mean? What is it I need to configure? I think that was supposed to do, but some autocorrect has kicked in there.
What is it important to configure?
Important, maybe. Back-end state store is an important one.
We all got it.
Otherwise, every time your machine changes, you lose your state or it gets confused. What's the name of the compression package that was found to contain an SSH backdoor recently? Certainly one for the security people on the call.
Really, a SSH backdoor, really? Okay.
Yeah. It was XZ.
Okay.
The Americans in the audience, which was, yeah. If you want a good story, go and read the GitHub logs for how that was found. It was a Microsoft researcher that found it. Which Microsoft product celebrated its 29th birthday at the end of March? It's Microsoft Bob. Congrats to the one person that got that one right. Which F1 team, Formula One team, did Microsoft sponsor? New season started. We're about 4 races in, I think, if anyone's interested. Unfortunately, we picked a rubbish one. Alpine is the answer. They're not doing very well. Which of the following is not an infrastructure as code technology?
Matthew.
All right. A lot of feedback there.
That was like a rave from the 90s then.
Yeah, I hit the wrong mic button. Don't Microsoft have something to do with McLaren as well, though?
No, it's Google. Google
switched.
Yeah, they're all over. So if you, even the wheels are like the Google logo on the McLarens these days.
No wonder they're not doing very well.
No, I think that McLaren use a lot of our tech from memory. What's the audience required for workload federated identity in Azure? This was mentioned.
It always astounds me how you get the questions that actually get covered. That's amazing, Matt.
They're all lucky guesses. I just get lucky a lot of the time. It was the one that got chopped, unfortunately. It was the Azure AD token exchange. Yes, it has cut in length. You're quite right. Which product will no longer be bundled globally as part of Office 365 or M365 as it is now? I think it's the last question. Memory serves me right. I didn't put the music on tonight. The answer is Teams. Our winner is whoever decided to put the bolt.
That's old D, right? So remove me from there. So yeah, it is you, D. We're not, you're not kind of double bluff us. That's all right then. So right, do me a favor then. So D, Jen, £25 Amazon vouchers coming your way. Eric and hang on, have I missed? Yeah, missed me. Eric and Jim Boy, you've got, so Eric, you've got the CICD ebook coming, and Jim Boy, you have got the IoT book from Packet, the ebook coming over. So can you do me all a favor? Either, if you don't mind, dropping your, like, who you are, Jim Boy, your email address with your name, either in the chat or on LinkedIn if you're following me, or Twitter. Find one of us. If you can put it in the chat, great. Just give me your email address and your name, and I'll get the prizes all. Oh, it is you, Alan. Jim. Okay, cool. So yeah, Brill. So hang on, which one's you? Jim Boy, you're James. I'll remember that. I know you, D. That's all right. Let me take a quick snip of the screen, because all these prizes now, I'm bound to get something wrong, aren't I? Right, is everybody dropped there? Yeah, we've got Eric. So Eric, you're obviously Eric. That's good. You can work that one out. So I'm just snipping the screen. Brill. Great, I've got that. Right, leave that with me now in the next couple of days. Have a look in your inboxes. You'll have either a link to an ebook or you'll have your voucher on the way. So brilliant as always, Matt. I'll wrap this one up now. Let me drop back over to the...
drop off mine.
Yeah, I'll quickly get back to the slide deck and bring this one to a close. So there we are. So there we go. Thanks, everybody. Yeah, great cover session again. Huge thanks to Jake and Nara for joining us tonight and imparting us with their knowledge, and obviously huge thanks to everybody that's given up their time to listen in tonight. Hope you've enjoyed the sessions as much as I have. Like I say, you listen to the basics on Terraform and get to something deep and technical as Workload by Identity Federation. They've all got their learning points to take, and it's been quite an interesting one again tonight. So huge thanks to the speakers again. Yeah, like I say, we're a community use group session, so please do help us spread the word. The next session will be on the 22nd of May. usual time, 6:30 p.m. UK time. If you can scan that QR, if you've got a couple of moments to give us a little bit of feedback, like I say, if you want to speak at the event, there's, just put your interest in there as well. Brilliant. And there we go. Alan's on point with the football scores. Not that I follow football, but I'm sure somebody does. Real Madrid 1, Man City 0. There we are. But on that note, thank you all. We'll catch you all next month.
Thanks, everyone.
Thank you.
Ta-da, bye.
Cheers.
Bye.
Bye. Bye.